Well, very good afternoon to everyone. So today we will continue our discussion about the linked list, and already done. We have seen the logics of implementing the single linked list and single circular linked list. In the single linked list, we have seen how to implement stack using linked list. We have seen queue using linked list. Then we have seen how to insert, uh, create a sorted linked list, single linked list. And in my previous class, I discussed about how to implement the circular linked list. So today we will talk about double linked list, and then after the completion of double linked list, if time permits, we will discuss about the double circular linked list. Otherwise, tomorrow we will wind up this particular topic. So you know very well that what is double linked list. So a double linked list is a linked list where each node contains three parts. Each node is having three parts here. So uh, the information part, the two address parts, in which one address part contains the address of the next node, and one address part contains the address of the previous node. And the next address part of the last node contains null, and the address part of the previous node, the previous address part of the first node will contain the address of the previous address part of the first node also contains null. Okay, so this list, how we are supposed to implement, we will see today. Okay, so again, I will just show you the execution of the program, how we are doing here. So I have just implemented the program. I will execute the program, then I will discuss. So I'm inserting the node 1, so some name and the number, and again 1. See here. So 4 nodes have been inserted. So if I am weaving, so now see here. So I'm just able to display the contents in both the direction. Either forward display and backward display is also possible in case of this linked list. Okay. Got it. Now if I delete the node also, so second choice. So if I give the name which is not there on the list, again it will say name not found. And now if I delete the node, if I delete the first node, the node is deleted. Now if I view it, see here, the first node is deleted. So likewise, you can delete the remaining nodes also. The last node is deleted now. Again, if you see here, the SSSDDD is displayed, only 2 nodes information is displayed. Again, still if I try to display, no node exists, is displayed. Okay, so this is how we have implemented the law, means that is what is the execution of the program. So the next thing here is we will now see how actually we are going to implement the logic. Here it is. This is a program where we are going to we have created a structure now. What is the difference between the previous structures and this structure which are using? And my voice is my voice audible to everyone?
Yes, sir.
Okay, okay.
Yes, sure.
Fine. Now, see here, I'm going to take 2 pointers now. Previously, we have just taken only one pointer, the self-addressing pointer. Now we are going to take two self-addressing pointers. One is the next and one is the previous day. The names, that is up to you. Which name you are going to use is up to you. But I'm using here next and previous names. Then we have head and tail pointers, which stores the address of the first node and last node respectively. Then we have the three methods here: insert, remove, and display, which are actually used to insert the node and remove the node and also display the contents in the list respectively. Now, the same like menu is displayed. If it is insertion, removal, and display, we have to enter the choice 1, 2, 3. Then if it is 1, okay, then it will go to the insertion part. And now let us check now how the insertion part works here. No. See, initially, so a node is created with P, a new node is created. Assume that this is all things are not there. Assume that we don't have any list here. So a new node is created. Okay. So now P is equals to struct phone, malloc of size of struct phone. Then enter a name and enter phone number. So a name and phone number are this entered. So P next and previous are stored with null values. So assume that I have entered a okay. So P next as well as P previous both are having null value. This is pointing here. Now the next question here says that if it is a first node. So this is if it is a first node, what is it? If head is equals to null, then head is equals to tail is equals to P. Both head and excuse me, both head and tail will be pointing to P here. So, head is also pointing to P, and we have tail which is also pointing to P there. And then we are going to go back from here because the insertion is done. Okay. So if suppose now we have the second node. So if it is second node, now P now will point to this one, the new node. P will be pointing to this node now. For example, so I entered the content addresses and 222, and we have P next and P previous both are pointing to null. both are pointing to null. Then next, what's it? Is head is equal to null? Head is not equal to null. It will come to the else part. So when head is null only when it is a first node. So it comes to the next part. Then tail next is equals to p. Tail next is this one. Tail next is equals to p. So here the null is removed and tail next is equals to p. This null will be removed. Tail next is equals to p. Then p previous. So p previous is this one. P previous will be equals to P previous is equals to tail. Okay. So tail contains the address of this node. Okay, the first node. So P previous is equals to tail. So this null is removed. And now P previous will have tail. What tail contains? Tail contains the address of this node. This node. Then again, what we are saying? We are saying tail equals to P. Now tail is changed to P. See here how we have linked it. So this is how we are going to link the content. That is the second node. Now if it is a third node, now let us create one more node, one or two nodes again. Now this time, so P, the third node I am creating. So it is pointing to this one, third node. So let us assume that this contains the content BDD and 333. Okay. So this is null. This also contains null. Again, will come with the same code. Tail next is equals to P. So tail next is this one. This null is removed. Tail next is equals to, of course, is pointing to this. Tail next is equals to P means tail next is equals to P. So this one. And P previous is equals to tail. P previous is equals to tail in the sense this one. P previous is equals to tail. This is removed. Null is removed. P previous contains tail, and tail is equal to previous. Sorry, tail equals to pre. Or P will be pointing, tail will be pointing to this one. Okay, so like this, we are going to create the entire list there. One by one, we are going to add and we are going to move on. So as an assignment, what you can do here is you can create a sorted double linked list. You can go for creating a sorted double linked list where as per sorting, I mean in the sorted order, you can insert the nodes. To try an assignment for that. Okay, it will be very interesting for you if you really try, because remember the magic of programming is if you try to code by yourself. It will be very, very interesting. If you are successful, you'll feel very happy. At least you'll have 100% satisfaction that I have written the code. So, to believe me or not, this particular code for you people I am writing after you don't want believe me. So I am right. I have written the code for these programs after around some 14 years, 13 to 14 years. After that, I am teaching the data structures now, because the data structures were not included in the previous syllabus, and if though it is included, some other teacher has taught it, but this time I have taken the data structures and teaching. So after 14 years I'm coding this, and I'm really feeling very excited to code these all things. Okay, so just try to make other alternatives also, like storing the data in the sorted order, create your own structures, and then try to implement the code. Okay, anyhow, this is how we are going to create a double linker list, the insertion part. So any doubt for anyone?
No, sir.
Okay.
No, sir.
No,
Got
sir.
it. This is a simple code which I have developed. Next is about how actually to display the contents. The second, the other portion is how to display the contents. Displaying the contents in the sense here, I have intentionally written the code to display both in the forward way and the backward, means the forward display as well as the backward display. Means how to traverse the list in the forward direction and how to traverse the list in the backward direction. So now, happy is head is equals to null. If head is null, no node exists. Right now, we are actually having a list which contains some content. So then we initially assigned p to head, and in the forward display, printf name and phone number are displayed. P name and phone p phone number means AAA and 111 will be displayed. Okay, then P is equals to P next. Now P next contains address of this SSS node. So now P will be pointing to the next node while P not equal to null. While P not equal to null, so it will go back and do again P name and phone number. This time P name is SSS, P phone number is 222. P is equals to P next. Now P next will be pointing to the node which contains DDD. Okay, then while P not equal to null, it will go back. Okay, again it will display P name and phone number. P name will be DDD, P phone number will be 3333. Then P is equals to P next. So P next will be pointing to FFF. Okay, so while P next means not equal to null, it will go back. Again, it will display the P name which is FFF. P phone number will be 44. Then P is equals to P next. Now P next contains null. So this time P not equal to null is false, because P now contains null. It is going to come out of this loop. So that is the forward display. Then we have the backward display, where we are going to assign P to tail. Simple, because we are using both the head pointer as well as tail pointer. Now P is assigned to tail. So in the backward display, the same procedure. So P will be assigned to the node which contains the FFF. So while do P FFF means P name and P phone number, FFF and 44 will be displayed. Now this time P is equal to P previous. We will say P previous. P previous contains the address of the node which contains DDD. So it will come, P will be pointing to this node. Then it will display the contents DDD and 333. Then P is equals to P previous. Now P previous contains this content. Now it is pointing to this particular node here. Now P name and P phone number will be displayed. Then P is equals to P previous. Again, it will come back here to display AA and 111. Then P is equals to P previous. This time P previous contains null. Okay, that's the reason it is going to quit it. So the same simple code we are going to use to display the contents. Right. Next is about the removal. Okay. While removing again, the thing here is say first you need to scan the name, which name you want to delete. So enter the name you want to delete. You're scanning the name. If head is null, initially you are saying that no node is existing, then you are going to return from here itself, because when there are no nodes, so you can't delete it. Then the first case which we are going to take up here is if you are supposed to delete the first node itself. So if you are supposed to delete the first node itself, then what you have to do? So while say this particular highlighted code deals with two cases here. The first case is if only one node is existing. So assume that if there is only one node existing, what you are going to do? So for instance, assume that now here I will make it. Assume that suppose we have only one node. Okay, so this is only node which is existing. Then it is one node, both head, tail will be pointing to the same node. Both head will be pointing to the same node as well as tail will be pointing to the same node. So this is the first case which I am discussing. Now, if it is the first node, then simply we should make head is equal to null and tail is equal to. So how will you confirm that it is only one node? Okay, if head next is equals to null, because it is a it contains the list contains only one node, the head next or tail or head previous will contain null values. Okay, so that's what we are checking here is so we are pointing P to head, is head next is equals to null. If head next is equals to null, we are saying head is equals to and tail is equals to null, and you are freeing the P and you are saying node is deleted and you are going to return. Got it? So if head is null, head next is equals to null, you're simply making head null and tail null, and then you're going to free the P, means you're going to deallocate the memory. You'll display the message node is deleted and you are going to return. Otherwise, if suppose you are not having only more than one element and you are supposed to delete the first node. If you are deleting the first node, then you have to move the head to the next position. So what we are doing, see here, else head is equals to head next. So of course here I can say you have P which is initially pointing to this node. We have made initially which is pointing to this node. Okay. After the code, so we are saying head is equals to head next. Head is equals to head next. Now head previous is this one. Head previous is equals to null. No, actually it contains the address of the previous node. So this is removed. This is removed, and now here null is stored. Right, null is stored, and free. Then you are saying free P. Free P in the sense this node is deleted. This node will be deleted. and then you are going to return. Got it? This is how you are going to delete the beginning node. And if suppose it is not the first node you are supposed to delete. Assume that you are not the first node you are deleting it. Assume that you are going to delete DDD. Then we'll come to this part. So P is assigned to head initially. P is assigned to head while P next not equal to tail. If it is not the last node which you are supposed to delete, and strcmp of P next name. P next name. What is P next? The address of SSS, and the name is SSS. So SSS comma DDD not equal to 0. True. SSS comma DDD not equal to 0. Then P is equals to P next. So we are now pointing P to the next node. Here it is. Okay. Then again, while P next not equal to tail, P next is not equal to tail, and strcmp of P next name. What is P next name? P next name is DDD. DDD comma str is also DDD comma DDD not equal to 0. Now it is false. Actually DDD comma DDD equals to 0. Then it comes to here. If strcmp of P next name is DDD comma str DDD equals to 0, then T, first of all, we are having T which is pointing to this node. You made the node pointed to this one. As per the code. Okay. P is equals to P next. It is pointed. Now, see these two lines. T next previous. T next previous. What is T next previous? T next means the address of the next node, and its previous means this particular part. T next is this node and its previous is this part. Now this should contains what? The address of SSS. Where is address of SSS? The address of SSS is in the T previous. The address of SSS is in the T previous. So what T previous contains should be assigned to this one. Understood? Again, I am repeating. So T next previous. T next is this one and its previous. T next previous is this one is equals to T previous. Now T previous contains the address of the previous node. So now it should point now to this one, T previous. So T previous contains the address of SSS. Now this is now pointed to this node. Okay, next. What is the next statement here? T previous next. What is T previous next? T previous means this node and its next. Now this part. T previous next. Okay, so this particular T previous next. Now should point and takes the address of FFF. Where is the address of FFF? It is there in T next. So that's what I have done here. So T previous next is equals to T next. T previous next is equals to T next. Now it is pointing to this one. Okay. So after linking like this, after linking like this. So what if t is equals to tail, if t is equals to, then I'm making tail is equals to p. Means if it is the last node, then I'm bringing tail to p. Okay, otherwise I'm saying free t. So when I say free t, observe this particular node will be deleted. And still we have the link which is maintained here, if you observe. Got it? So this is how we are going to delete the node here. Okay. Understood, everyone?
Yes, sir.
Okay.
Small confusion, sir. That previous next and that part only, sir.
Yes. So just I will repeat it once again. See, I will repeat it once again. So we are saying this is all. TP. So after pointing T to P next here, what we are saying here is T next previous. T next is this one. That T next actually contains the address of FFF. So its previous is this node, this particular thing. T next previous should contains T previous. What is there in T previous? The address of SSS. The address of SSS. So now this one which is actually containing the address of DDD should now contain the address of SSS. Okay, so T next previous is equals to T previous. So when I say T previous, so now this is actually pointing to this one. Got it? Then we have T previous next. T previous actually contains the address of SSS and it's next. Now this particular where my mouse pointer is actually moving. So this one should contains the T next. What T next contains the address of FFF. So now this actually this address is removed and now it contains the address of the FFF. Like this we have linked this, then we say if t is equals to tail, if it is the last node, then I have to make it to p because it is not last node. So this is not actually taken into consideration. When it says free t, simply what happens is this particular node will be deleted. And still we have maintaining the link here. We have not lost the link. So only thing here, if you remember when we develop the linked list, you need to connect the nodes properly, because to traverse them, that's the only major part. Whatever the content you are storing, whether you are storing the employees data, student data, XYZ, whatever kind of data you are storing, that doesn't mean that. But how well you are going to connect these nodes so that the no node information is lost, and you can, if you are able to retrieve the entire list here, then it is fine. It is okay for you. Got it? Any doubt for anyone?
No, sir. Thank you.
Okay, fine. So I will be sharing the content today. So immediately after the class, just go through the code, make a list like this on the paper, and then you practice this more than once. So when you practice more than once there, then you will understand. If you are have any confusion, you can play back the video once I share the video link. Then you listen back and you try the code once or twice. Then it will be easy for you. Okay.
Yes, sir.
Okay, thank you. So